To understand why they'd hide it, you need to go back. The hidden briefing, seeds of a secret program. They called it a performance review, but the room knew better. The year was early, the pressure absolute. A slide showed descent V budgets and thrust-to-weight curves anyone could quote. Another slide, quiet, almost apologetic, showed how quickly those curves collapsed when the lunar module got heavier, when landing sites pushed rougher, when guidance margins thinned. The official engine could throttle, yes. The descent propulsion system had been tortured into a marvel, 10% to 60% throttle, gimbaled helium tricks just to keep the flow stable. On paper, it all closed. In simulation, the numbers squinted back. A junior analyst coughed into his sleeve and advanced to a plot the chiefs didn't like seeing outside the building. It was a stress map of the landing envelope, color bleeding toward red in the final 1,000 feet. The narrator called it politely tight. The more honest word was unforgiving. Someone asked about revising public specs. The answer was immediate. No, the nation was watching. Change the declared hardware and you change the story. A second voice added what everyone understood. The White House would not accept slippage. The Soviet program wasn't going to wait for anyone's conservative redesign. Then came the memo, the one people pretended not to have seen while making sure it stayed close. Narrow distribution, unreadable paragraph titles, the kind of language that sounds bureaucratic until you translate it. The essence was simple: explore non-traditional augmentation approaches to create stability windows during final descent without altering declared performance or interfaces. The phrase non-terrestrial anomalies appeared as a justification for a parallel materials survey. It was a door left ajar, not a claim. But in rooms like these, ajar doors invite careful footsteps. A contractor's shuffle followed. Lines on org charts split and recombined, and new shell divisions appeared with adjectives like advanced and special. A lab that had been chasing heat exchangers got a new access list and a narrower nameplate. People were read in not because of title, but because of what their hands remembered: fluid stability, acoustic resonance, the way metals behave when you push them past comfort. Clearances arrived by odd routes. Badges unlocked only 2 rooms and 1 hallway. If you needed to know, you would be told exactly what to build and exactly what to call it, which would not be the same thing. The engineer we're following, call him Warren because names still matter, didn't think of himself as clandestine. He'd come up through test stands and shop floor fixes, the kind who could pull an all-nighter with a busted injector and a deadline. His offer letter read like any other, except for a line he almost missed: concurrent assignment to special materials characterization tasking. The briefing that came with it was short. He would be supporting an internal study to reduce descent risk. He would never refer to it as propulsion. He would sign a new NDA with clauses about recovered evidence. The phrasing chilled the room, but no one asked for a rewrite. The special materials lab lived behind a door that didn't exist on the floor plan. On his first day, Warren was handed a stack of sanitized test reports from unrelated projects. At least that's what they looked like. Between lines about thermal subloop behavior and acoustic susceptibility, he saw the outline of something familiar: oscillation windows, brief bursts of unexpected impulse, a note that said in pencil, "Don't chase steady state." Warren's first task wasn't to design, it was to listen. The team had split into materials, field behavior, and an odd little group that spent nights aligning transducers and complaining about noise. Somebody taped a printout on the wall, a convex, unforgiving landing envelope colored like a bruise. Underneath it, in a different hand, someone had written, "Make it green for 2 seconds." The directive was impossible and obvious at once. They didn't need a new engine, they needed a moment. An incremental, deniable nudge that would show up as health in the guidance numbers and stability in the commander's hand, not as thrust you could point to on a diagram. They needed it to ride inside what already existed, interface where nobody would see, and disappear the instant anyone looked too closely. Warren learned new words for old instincts. A cover taxonomy meant calling a coupling a cooler. A ship-end swap meant routing a box through a vendor everyone trusted, then diverting it to a bench the vendor would never know about. Plausible, the chief kept saying, not perfect. Perfect draws heat, plausible gets filed. In the evenings, Warren still went back to the official numbers. He ran descent simulations the way he'd been trained, with declared throttle curves and mass properties you could recite from memory. Sometimes the virtual lander kissed the surface like a feather. Sometimes a hiccup in timing turned feather into stone. He stared at the plots and felt the unease that had started this whole thing. He didn't think of aliens, he thought of margins. Then one night a crate arrived that nobody had ordered, signed by a name he didn't recognize. The receiving clerk logged it under thermal systems and rolled it to the lab that didn't exist. Warren's boss didn't look surprised. He just said, "We're characterizing, we're not publishing. Label it as a heat exchanger and start with the harmonics." That was how a hidden program really starts, not with a confession, not with a manifesto. with an unscheduled delivery, a cover story that sounds boring, and the understanding that if it ever worked, no one involved would be allowed to say why. The margin that didn't add up. Warren started with the public numbers because that's what everyone trusted. The descent propulsion system could throttle from 10 to 60%, gimbal 6 degrees, and hit a fixed throttle position around 95% of design thrust when you needed efficient braking. The guidance and navigation loop, tight as a drum, would fly the profile, descent orbit insertion, powered descent initiation, and the long, careful bleed of velocity into dust. On the page, it looked elegant. In a dynamics model with real-world jitter, sensor latency, and human reaction time, elegance frayed. He ran the Apollo 11 descent profile as documented. Mass properties that match the mission report, nominal propellant slosh modeled, landing radar acceptance gates as specs. Then he added the little things you only learn from bench work and post-flight debriefs. The way thermal soak shifts a sensor bias, the way a gimbal actuator hesitates when it's hot, the way the computer has to juggle tasks and sometimes yells 1201 or 1202 because you've asked it to do too much at once. Most runs came home, too many didn't. It wasn't failure so much as a narrowing of chance. The envelope was flyable but unforgiving. In the last 1,000 feet, with throttle low and engine response sluggish by design to avoid instability, there were tiny windows where an unexpected sink rate could become a cliff. The guidance could catch it if the radar updated on time, if the computer didn't shed a task, if the hand on the stick trusted the numbers and not the gut that said, get away from those boulders. Change one assumption and the safe landing moved from probable to coin flip. Conventional tweaks were the first instinct. Could you nudge throttle response without inviting combustion instability? The old hands shook their heads. The helium injection tricks that kept the flow stable had their own edges. Push past them and you got oscillations you didn't want. Could you shave mass? Every pound had already been fought over. Could you dial guidance more aggressive? That meant more computation exactly when the computer was already crying uncle. Every lever was attached to another lever. Tug 1, the panel creaked somewhere else. Simulation plots looked like a weather map nobody wanted to read. Red bled into yellow at precisely the moment the commander needed margin. Warren tried to be clever. He modeled a slightly higher FTP, saw the familiar spikes in chamber pressure and the risk of cavitation. He slotted in an extra task for prioritization and watched the 1201 window open wider. He tried a fantasy version where the engine could give 5% more for 2 seconds and then pretend it hadn't. The model relaxed, the bruise on the envelope lightened. He stared at the fantasy plot and wrote unhelpful in the margin. Fantasy wasn't policy. But then came the note anonymous, tucked into a stack of thermal subloop memos as if it were a misfiled addendum. It used careful words: auxiliary impulse module, augmentation window, harmonic engagement criteria. It didn't propose changing the engine. It proposed coupling a transient field to the structure in a narrow band, not to add thrust in the rocket sense, but to bias the way the whole stack responded to tiny oscillations in the final phase. In plain speech, make the system settle faster when it mattered most. Don't call it thrust, call it stability. Hide it where heat and vibration were already noisy. Warren took the memo to his boss and got a look that said more than the words. It's exploratory, the boss said. You'll help characterize, you'll never use propulsion language. The subtext was louder. This wasn't a tweak in a public spec. This was an insertion no one could brief on a tour. When the crate showed up, the models gained a companion, a bench with a lattice that didn't match any machining they knew. The first test didn't make sense if you thought in steady state. Inject a specific acoustic profile, a narrow harmonic near a few kilohertz, and sensors on the lattice nodes reported behavior that looked like the system was momentarily lighter, not less mass, just less reluctant to respond. It wasn't continuous, it was a burst, 2 seconds, maybe less. Then everything returned to exactly the same, as if whatever field had bloomed had shut itself off. They weren't measuring thrust on a load cell. They were measuring the way an already oscillating system changed its tune. Coupling, not pushing. The language got careful. Damping augmentation, transient stability, thermal subloop harmonic gate. In meetings, Warren heard the same directive in different words. Do not alter declared performance. Do not alter interfaces. Do not create signatures that can be heard outside the intended channel. The more they understood what the module could and couldn't do, the more it lined up with the descent pain point. It couldn't lift you. It couldn't save you if you were far off the mark. It could, when the vehicle crossed a specific velocity and altitude threshold, make the guidance numbers calm down faster. It could turn a wobble into a glide. It could buy seconds when seconds were the only currency that mattered. He folded the augmentation model into the descent sim, not as thrust, but as a transient change in damping coefficients keyed to a band-limited input. The result wasn't dramatic, it was decisive. The bruise on the landing envelope softened right where human decision lived. The coin flip shifted back toward skill. Warren closed the run and looked at the clock. Outside, the nation believed in bravery and equations. Inside, he was watching how a crate with no vendor tag might turn math into margin, and margin into a landing no one would ever admit had helped. The crate recovered hardware with no paper trail. It rolled in after midnight, logged under a work order that matched nothing they were doing and everything they could explain away. Thermal systems, the paperwork said. Destination, the lab that didn't exist. The night clerk slid the manifest across the counter, finger tapping a signature block with a name Warren didn't recognize. Not a vendor, not a program manager, just 5 letters that belonged to no directory. The clerk shrugged, came on a truck with no logos. Driver didn't shut the engine off. They broke the crate on a bench nobody photographed. Under a second lid screwed, then resin sealed, lay a framework wrapped in neutral film. Warren reached for the edge and felt cold that wasn't room temperature cold. It was the kind of cold metals keep inside themselves when they won't share with the air around them. The film peeled back with a dry whisper. Everyone leaned in. It wasn't a block, it wasn't a tube. It was a lattice, thin ribs forming hexagons nested inside hexagons, nodes thickened like knots in a net. You could see through it from most angles and still lose your place, the way eyes lose their grip on certain patterns. No welds, no machining spirals, no tool marks. The ribs met each node as if the entire thing had grown from one intention rather than been assembled from many. Warren touched a node with the back of his fingernail. The texture was wrong, not rough, not polished, something that deflected sensation, like feeling the surface of a liquid that refused to wet your skin. He glanced at the others. One of the materials leads mouthed a word that could have been impossible or beautiful. In this room, the difference mattered less than the implication. They weighed it too light for its volume, lighter than an equivalent aluminum lattice would have been by a margin that asked questions. They scanned it. The response jittered in ways their equipment wasn't calibrated to interpret. They micrographed a shaving from an edge. How do you shave what has no obvious grain? And the cross-section showed channels inside channels, a geometry that ducked away from their resolution like a fish refusing the net. The tag attached with a wire was a single line, experimental heat exchanger assembly handle with gloves. Warren smiled at the accuracy of the lie. He wrote HX subassembly on the bench card and initialed it. The chief nodded approval. Cover taxonomy first, curiosity second. On the test stand, they started where any engineer would, dumb loads. Clamp it, measure stiffness, ping it with controlled taps, and listen for the ring. The acoustic team perked up. The ring wasn't a ring, it was a flock. Multiple modes bloomed close together, then disappeared when you nudged frequency a hair. They rolled in transducers and drove a slow sweep. At a few kilohertz, the structure drank energy like a throat you couldn't see, then gave it back in a phase that made their plots tilt in ways they didn't expect. They bolted accelerometers at the nodes and along the ribs. The node readings behaved like leaders in a dance nobody taught them. The ribs lagged and then snapped into phase when the drive hit certain windows. Warren wrote harmonic gating in the margin of his notebook and underlined it twice. The directive from upstairs came down as calmly as oxygen. Characterize, don't publish. Label all results as thermal subloop behavior. If anyone outside your list asks, it's a cooler with unusual susceptibility to vibration. Do not use propulsion language. Do not use the words thrust, lift, or delta V. He copied the rules onto the whiteboard, then erased the verbs and left the nouns. They built a harness that could pass an electrical input through a pattern of contacts printed onto the lattice like a circuit that didn't want to admit it was a circuit. Drive current at low levels did nothing. At higher levels, the structure warmed in a way that refused to map to resistance. They turned the current off and felt the bench cool as if the heat preferred the lattice to the air. The materials tech grinned. If it's a heat exchanger, it's the strangest one I've ever met. Then came the moment Warren would remember when he was old. They mounted the lattice onto a mock-up panel that mimicked the stiffness of a load path in the lunar module mid-body. They didn't tell the mock-up what it was wearing. They injected a narrow acoustic tone, while the panel was excited with a low-amplitude tremor that stood in for the background shake of a throttled rocket. At 3.2 kilohertz, give or take a tenth, the accelerometers along the panel reported a change that wasn't a change. The same input force produced a cleaner response. The wiggle settled faster. The numbers, if you believed them more than you believed your instincts, said the system had just decided to behave as if it were more stable than it had been 1 second before. 2.5 seconds later, the effect vanished. The tremor reverted to its nervy self. The panel felt ordinary again. Warren looked at the clock, he looked at the trace. He wrote burst 2.5s on the board and circled it. Somebody whispered, "Do it again." They did, it repeated, not every time. Only when the tone, the temperature, the clamping pressure, and the way the panel was already shaking lined up inside a narrow tolerance that made sense if you stopped pretending this was about steady-state heat and started admitting this was about fields. They took off the harness, they put it back on, they swapped panels, they changed nothing and everything. The pattern held enough to be real and slipped enough to stay deniable. It wasn't thrust on a scale. It was a finger on a violin string, coaxing the instrument to sing a pure note while the orchestra tried not to notice. The formal label on the test report read, Thermal Subloop Harmonic Susceptibility, Observed Transient Damping Augmentation under Controlled Excitation. The informal label, shared only in the room, was simpler. It wants to help, the acoustic lead said softly. Warren signed the report, filed it under the Covert project, and put his notebook back in a drawer with no label. He looked at the lattice and allowed himself the thought the directive didn't permit. If they could mount this where the LM already vibrated, if they could excite it without adding a switch anyone could point to, they might be able to buy the commander 2 seconds of calm exactly when the world turned unforgiving. He closed the drawer and for the first time felt fear that wasn't about failing. It was about succeeding in a way no one would be able to explain. Reverse engineering the impossible. They didn't start with confidence. They started with tape measures, calipers, and arguments about what they were even looking at. The team split the way good teams do when they know one approach won't be enough. Materials took custody of shavings and thin films they could coax off a non-edge without changing its nature. Field behavior took the benches with the sensors, mapping what the lattice did when the world poked it. The odd little subgroup, 3 night owls with a fondness for speakers, piezo's, and tone generators, claimed a corner and a stack of foam to kill reflections. They called themselves the choir and nobody told them not to. Warren floated between them. Materials came back first with the bad news every reverse engineer knows. What you can see is what matters. Under the scope, the lattice wasn't a single alloy at all, not in the way they could name. It behaved like layers that refused to admit they were layers, channels braided into channels, grain boundaries that looked more like decisions than metallurgy. When they ran a standard spectrum, peaks were there, but signature lines were faint or doubled, like the element wanted to be 2 things at once. Field behavior logged windows as if they were tracking weather. Sweep too fast and you missed the bloom. Sweep too slow and the bloom didn't appear, as if patience made it shy. Temperatures mattered, clamp load mattered. The choir kept marking the same band with a Sharpie on the whiteboard, 3.1, 3.2, 3.3 kilohertz, as if writing the numbers pinned them down. It didn't. The numbers moved a hair with temperature. They moved with how the mock-up panel was bolted. They even moved with which humans stood closest to the rig, a superstition nobody wanted to formalize and everyone respected. They tried to replicate with earthly metals because that's what you do when you can't name what you have. The shop cut a clean hex lattice from 70-75 aluminum plate and a second from titanium because someone wanted to be fancy. They matched dimensions, node radii, rib thickness. The choir smiled and played the same tones. The aluminum sang the way aluminum sings, good, predictable, dead at the edges. The titanium refused to drink energy at any tone. The mock-up panel did what mock-up panels do. Nothing changed. The earthbound analogs didn't collapse, they just refused to be interesting. Back on the original lattice, the effect was stubborn and narrow. It's a keyhole, the acoustic lead said, tracing a fingertip over a plot that looked like a mountain range with one useful pass. You don't get to fly over, you thread it. They found out what happened if they drove harder, because of course they did. The bloom came faster and then flatlined. The structure went dull. They waited, nervous. 20 minutes later, the bloom returned like a heartbeat that just needed a breath. Warren wrote recovery necessary and underlined it. We don't own the cycle, he said, and nobody argued. Power coupling became the next wrestling match. They had printed contacts that made the lattice act like it wanted to be a circuit on Tuesdays, but not on Wednesdays. Low current did nothing. Moderate current altered the way the bloom appeared, shifting the keyhole left or right by a fraction of a kilohertz. High current pushed their luck. The lattice warmed in a way the thermocouples reported as a rumor more than a fact, and everyone backed away. The only knob we own is the song, the choir lead said. Sing right, it answers. Yell, it shuts the door. The penny dropped on a bad night that turned good. They'd been trying to make the lattice act like a thruster because the human brain wants rockets to push. The curves refused. Warren stepped back, looked at the mock-up panel, the accelerometers, the guidance plots from his sim, and said it out loud. It isn't a prime mover, it's a booster. A nudge in a language the structure already speaks. The room was quiet the way rooms get quiet when an idea makes everyone feel silly and relieved. He built a translator between worlds, an interface that lived inside the LM's legitimate wiring as a thermal subloop monitor, because that's what the paperwork would say. He looked at vibration the way the guidance system already did to protect sensors. It listened for the keyhole. When the vehicle crossed a descent window, sync rate, altitude, throttle setting would let the choir sing in a whisper the commander would never hear. 2 seconds, maybe less, then off. No switch to point at. No new throttle curve, just a moment where the numbers settled faster than nerves. They proved to themselves it could be done without changing interfaces, because that was the hill they would die on if they didn't. The harness drew less power than a forgotten light bulb. The tones rode on wires already thick with legitimate chatter. The excitation was band-limited to live where microphones and headsets wouldn't wander. They fired it into the mock-up while feeding the guidance box an honest descent profile recorded off a simulator. In the narrow window, the guidance filter spat out a smoother estimate a fraction of a second sooner. It was nothing, it was everything. Failure cascaded in parallel because progress never travels alone. The shop's best attempt at a duplicate lattice delaminated under drive, which was funny because there were no layers to delaminate. The material team burned weekends swapping deposition parameters on thin films deposited onto conventional honeycomb, pretending the pretense wasn't ridiculous. The choir blew a driver and spent a day soldering, cursing, and laughing. They updated the whiteboard 3134KHZ, safe window less than 2.5 seconds, recovery required. Next to it, in Warren's hand, a rule: never call it thrust. He wrote one more line under the rule because language, like hardware, controls outcomes. If this ever works, it will look like luck. He looked at the lattice, the mock-up, the plots that didn't brag, and let himself imagine a cockpit where a human hand felt the world calm down for just long enough to steer clear of a boulder field. Then he erased the line. Some truths were only safe as muscle memory. The cover story: hiding an engine in plain sight.